Since we're now learning about materials, we are learning about the substances that materials are made of, namely elements. And so we have to refer back to the periodic table. You may have seen this in a chemistry class or in a previous science class. I'm sure, well, I think most students have at least seen the periodic table. It's on the wall in a lot of classes. We're not going to go into detail about how to read and interpret what's on the periodic table, but we are going to look at some of the basics. In a carbon, well, a carbon is often used as an example. So in this carbon atom, if we look at any periodic table, it's going to have carbon represented by the chemical symbol C. It's going to have the atomic number of 6. The atomic number actually tells us the number of protons. The average atomic mass tells us the mass of 1 mole of that substance in grams, or the mass of 1 atom of that element in atomic mass units. And it tells us the element name. Now, if we look at the periodic table as a whole, we see that it's divided into sections. Okay, though I just drew a line through a group called or not a group, but a region called the metalloids. To the left of the metalloids, we have metals. So the metals in this periodic table are in blue. And then I guess it's kind of a greenish color actually, because the non-metals are on the right side of the periodic table. So we have metals and non-metals. Those are the two major groups. And then in between them, there are the metalloids or semi-metals. Now, atoms form molecules and extended structures such as crystals when these atoms of these elements combine. The number of protons in the nucleus determines the element. So carbon always has 6 protons in its nucleus. Oxygen always has 8 protons in its nucleus. The number of protons can only change in a nuclear process. So, you've heard of nuclear explosions, nuclear reactors. These are very highly energetic. Often they're often very highly energetic processes. They're not like chemical reactions. It takes a lot more energy to, it may release a lot more energy when a nuclear reaction happens than when a chemical reaction happens. A chemical reaction is always takes place between the electrons of the atoms. Usually we've talked about how most substances are neutral. That's because the number of electrons matches the number of protons. If you add more electrons, the atom becomes a negative ion. If you take away electrons, the atom becomes a positive ion. A single type of atom is called an element. A combination of 2 or more atoms in a distinct ratio is a compound, like H2O. It has 2 hydrogen atoms for every 1 oxygen atom. That's a compound. Or CO2, carbon dioxide. Atoms join through different types of bonds. They share or transfer electrons. If an atom gains an atom or a molecule gains or loses an electron, it becomes an ion. Metals easily share outer electrons, while non-metals cannot. We've talked before about how the metals make good conductors because electrons can flow through them easily. They're not stuck to one atom. Metals can easily share outer electrons while non-metals cannot, contributing to distinctive properties such as conductivity and shininess.